Before I built this robot here, every time a 3D print from the print farm finished, it looked like this. So I built a robot, and now when a print finishes, it looks a little more like this here. Welcome to the New York City Design Studio. My name's Austin. I'm a mechanical engineer, and for years we've been doing CAD design, 3D printing, manufacturing, game design, you name it. We live and breathe engineering. We love it, usually. However, you see, recently I was working on a project and we had to design 28 different small parts for that project, and it turned out that was the easy part, because when it actually came time for production and for fulfillment, there were thousands and thousands of orders, and all of those orders required different quantities of each one of those parts. Now, stay with me here. This will all make sense and circle back to 3D printing automation. So, for example, one customer might need 10 of part 1, 15 of part 2, 1 of part 3, all the way up to X number of part 28, which of course, you could do that by hand, but this made me realize we do need to be able to automate that production and that fulfillment. Here's a quick sneak peek example. Maybe you see where this is going, and yes, before you jump in the comments, yes, there are existing 3D printer automated solutions. Currently, when it actually comes to 3D printer automation, the most popular method that I've seen and that we've actually used and tested has been sort of the concept where the 3D printer actually prints the object and then it manually sort of pushes it off the build plate. And hey, for some people and some products and businesses, that's great. It can be relatively affordable. If you have the right product or the geometry, it can be relatively reliable. All that stuff checks out. That is not what we are trying to do or to compete with. My goal, or our goal here, is to take it one step further. And by one step, I mean 20 steps further. So the system that we're working on it's really completely different. Imagine being able to have your printers up and running, or your print farm, and you do something like, hey, 401 bot, go check on printer 5. And the bot moves over to printer 5. You see there's a failed print, and you say, hey, 401 bot, clear the print bed. And it cleans up that print, and then it kind of restarts, and you see where this is going. So I don't want to get into all the details right now, as I don't want to make a bunch of false promises. In fact, it is likely that this actually fails. Otherwise, it probably would have been done by now, but I do want to show you the process along the way, which is why I'm making these videos. I do really believe that in terms of true production and true fulfillment and automation, it will be possible with the robotics system that we're working on. The question or the challenge is not actually if we can do it, it's more if we can do it and get that price down to a level where people would actually be interested in this product or service. So right now, for example, I could buy a robot off the shelf for 30 to 50,000 bucks, and it would do everything that we needed to do. The limitation is not the technology, the limitation is the cost of the technology right now. And I believe that we can make it a lot cheaper and actually better, because it will be made for this purpose. Going on a rant, back to those 28 parts that I was talking about. Now, the goal with automation, and this is the goal with most 3D printing businesses that sell the same catalog of items, whether it be cookie cutters or planters or gadgets or tools, you name it, the goal is to effectively manage inventory. So what happens is an order comes in, hopefully you already have those items printed and stored somewhere. Those items get put in a box and shipped out to a customer or client, and then you restock inventory when it gets low. Now, yes, this is 3D printing, and you can just have an order come in and then print it and fill the order that way, but that doesn't really work at scale. And if you've been 3D printing for a long time, then, well, you know why. So that entire inventory management system or process can be automated. In fact, the actual fulfillment of it can even be automated. Imagine those 28 parts. You have, say, 28 drawers or buckets, or however you manage your inventory. Order comes in, the robot goes, it picks all the parts out of those 28 buckets that you need, puts them in a box, and you can go ship that off to your customer. And now when your inventory gets low, the robot can actually go and print more items, take them off the printer, and restock the inventory. That is kind of more where this is going. And the cool thing is that if the robot and if the system is able to do that, the possibilities are pretty endless and it can do so much more. And I'm really excited to share some of those cool things with you along the way. Now, I know that there's a lot of makers in this audience. So if you're interested in this robotics project, I am gonna put a link below where you can actually sign up, and we'll just shoot you an email kind of as things progress and keep you up to date with it. And as usual, feel free to drop a comment, talk about the ideas, rip them apart. This is an open discussion. Now, lastly, I do want to give a huge shout out. Thank you to Chris Annan. I'm going to put a link below to his work as well. We use his open source robotics project for our hypothesis testing, and he was even kind enough to answer some emails when I reached out to him there. So Chris, if you see this, or just for the record, Chris, thank you so much. Your project is awesome, and I will link that below. Anyone who's interested in open source robotics, I highly recommend checking that out. So that's it for this video, and I'll see you guys in the next one.